If you ever wondered why you can handle larger weights on a leg press machine than you can with squats, here is the explanation. It's got to do with trigonometry and the sine function. Take a look at this square here or rectangle here that I drew. Leg press machines are manufactured that usually there are vertical ones, that 90-degree leg press machine that you put the weights on, say 1 or 2 big plates, and you lie down on it and you're moving the weights vertically. They are not very popular because they're damn heavy to move the weights. The 60-degree machine is also popular. You can put some more plates on it and you can feel strong, and you're moving the weights on a 60-degree rail on the machine when you are lying on it on its bench. There's of course the very popular 45-degree machine, and what the heck, you can do more plates on this one. You can feel really strong about this one, and you're moving the weights on a 45-degree angle up and down on its rail. 30-degree machines don't exist, so I made a dotted line there, and 0-degree machines don't exist, but the continuum is obvious. 0 degrees, 30, 45, 60, 90. And this is what math tells us about the weight and sine function. I made a little chart here that concerns the weight loaded on the machine and the effort it takes to move it. Okay. If something is moving on a horizontal ground, you can, here is all of the weight there. You can have a huge weight on it and strongman competition. You can tow a Boeing 747 with your teeth, you know, and it's really easy. Okay, that really adjective needs to be treated with caution here. What I'm saying is that the weight and the effort, how they relate, you don't move any of the weight along a 0-degree plane or 0-degree incline. Okay, what you're working against is friction only. Friction with the road, friction with the rail of a machine. If there's a horizontal pressing something, say loading or pushing lumber on a sawmill, or I don't know, something like that. Okay, so if you have to move a weight horizontally, all you're fighting against is friction. You're not fighting against the actual weight of the thing. Okay, that's why a relatively little horsepower can move a huge 16-wheeler, like a trailer, a tractor, whatever. It is because the sine function of 0 degrees, sine 0, is 0. On a 90-degree situation here, you're feeling every ounce and every gram of the weight. Okay, whatever, because you're directly under gravity's pull. The force of gravity is going this way and you are moving it exactly the same way, in the same direction. So sine 90 is 1. You're feeling 100% of it. So if you load up 200 pounds on the leg press machine or whatever, you're feeling and handling 200 pounds plus the friction inside or whatever the system causes, but that's another story. So how the rest of the numbers relate is this. If you load up 100 pounds or kilos, whatever, and you move it on a 30-degree incline, you are only really moving 50 kilos or pounds on a 30-degree incline, up a ramp or down a ramp. If this one is 100 kilos and you're pushing in the direction of the incline, like so, you're only really moving 50, because the other 50 the rail takes, and usually a rail would bend under it. That's why nobody really makes a 30-degree leg press machine, because it would need super thick rails to hold up the weight. On a 45, the sine of 45 is 0.707. So if you load up 100 kilos on a 45-degree incline, you're moving 70. That's your effort. Okay, on a 60-degree incline, your effort is 86 kilos. The rest of it is taken by the rail along which the weight glides and a little bit of friction. Nothing is ever frictionless, but that's minimal. Okay, plus, yes, I know the carriage that holds the weight plates, the platform and the spindles that you put the weight plates on, those also have weight, but nevertheless the math is there. If you're working on a 45-degree leg press machine and you have 100 pounds on it, you're only moving 70 pounds. Really, the rest of it is taken up by the machine.